Okay, welcome to the guide sheet on waves. This is just general characteristics of waves and the nature of waves, which are a very important type of motion. A wave is essentially a disturbance, some kind of oscillation or vibration. It can either travel through a medium, like sound waves or earthquake waves, or it could travel through empty space if it's an electromagnetic wave, which kind of lays down its own electromagnetic fields to travel on. The basic characteristics of the wave can be seen here. The most important element is this black line that goes through the middle. This is called equilibrium position. And that's where the medium or the stuff that the wave is traveling through, if it is traveling through material, would be if it wasn't being disturbed. So think about taking a long spring and stretching it out, holding it straight across. That's its equilibrium position. If you disturb that equilibrium position, then you can generate a wave. Highest parts of the wave are called the crests. Lowest points of the wave are called troughs because they kind of look sideways. They look like a trough. A wavelength is any distance between any two like points. So here's a wavelength. This is also a wavelength. It could also be between here and here is a wavelength. Amplitude is from the equilibrium position to the highest point or the lowest point. So both of these are amplitudes. True and false here. True, waves are created by a vibration. Something moves, that motion sets a wave in motion, which then travels along through some medium, or again, if it's electrons that are vibrating, they might be an electromagnetic radiation. As the wave moves through a medium, the individual particles move is false. So waves don't transfer material, they transfer energy. The individual particles that make up the wave only vibrate back and forth or up and down. They don't move along with the energy of the wave. Therefore, 3 is true. Waves are a way of transferring energy without actually displacing matter from one place to another. That's going to make 4 false. The ocean wave transfers the energy, but it does not transfer anything in terms of the water molecules themselves. They move in some kind of, actually mostly a circular pattern, and stay in their own location. And 5 is going to be true. The individual particles of the medium undergo a periodic and repeated vibration. Part of studying waves is simple harmonic motion, so a motion that repeats itself over and over again. So here's an example of making one pulse on a wave. If you watch the little green particles, they only move up and down. They don't move along with the pulse itself. Restart that. If I make it oscillate, then I get a consistent set of waves. Then when they bounce back, I get this type of end here. Let's see. Let's go to no end at all and restart. So if I continually make the waves, then I get this nice long train of these disturbed particles. Now, when you're looking at it like this, it looks as though the object is moving. I'll slow it down for you. It looks as though the particles are moving along, but really, if you watch the green particles in the wave, they're just moving up and down. They're being disturbed, but they're staying in their own same place. Okay, in terms of how the wave is different from the pulse, the first thing I made there was a pulse. That's just going to be one disturbance. So you might make one motion with your hand on a spring if you're holding it. That's going to set one waveform or part of a waveform going along the string or the spring or whatever you're making the wave in. A wave is repeated sets of pulses. We often talk about it as a train of waves. So instead of just one car, you have one car after another. So you have one cycle after another, and you get several repeated cycles. Mechanical waves need to propagate through a medium, stuff. The reason they do that is the interaction of the particles. One particle pushes or pulls on the adjacent particle, which then pushes on the next one, and each individual particle does not displace itself, but the energy of the wave moves along. A stadium wave is the easiest way to see that. One person stands up, puts their hands up, the next person beside them stands up, puts their hands up. Each person is ending up back in their same seat as the wave moves along, but the energy of the wave, the motion of the wave, is going around the stadium. Again, in terms of which the two basic types of waves are mechanical waves and electromagnetic waves. The mechanical waves require a medium for the wave to move in. They have to have something to travel in. Electromagnetic waves can lay down their own electro and magnetic fields and travel along those fields, so they can travel through empty space. Sound is a form of mechanical energy, or mechanical energy. Sound is a form of mechanical wave. It can't travel in empty space. This picture is the general electromagnetic spectrum from longest wavelength to shortest wavelength, lowest frequency to highest frequency. These are the main sections: radio waves, microwaves, infrared waves. There's the little visible light spectrum that our eyes can see, the Roy G. Biv of the rainbow, ultraviolet for above violet, X-rays, gamma rays. This is not a complete list, but it gives you some idea of where the various types of electromagnetic radiation are. Okay, so we'll finish up this first video with what's wrong with this. Suppose you're watching a science fiction movie and you're out in the middle of the space and you hear what's going on. Star Wars is a great example. The very first Star Wars movie, the Imperial Star Cruiser comes over and you hear this noise. The problem with that is sound is a mechanical wave. Therefore, sound has to have something to travel through. It needs some kind of matter to travel through. Well, space is a vacuum, so there's no vacuum to carry the sound. So if there was a huge explosion in space, you still wouldn't hear it because there's nothing to carry the sound. You could see a huge flash of light, but you wouldn't hear the sound. It would be a little eerie, a little unusual. One of the reasons why movie makers tend to include the sound is people would kind of go crazy if they were watching a movie and they saw an explosion and there was no sound, because here on Earth there's plenty of air, plenty of material to carry the various sounds. Okay, so those are some of the basics. There are two basic types of waves, mechanical and electromagnetic. Electromagnetic breaks down into a whole spectrum of various types based on frequency or wavelength. Mechanical waves have to have a medium to travel in, but electromagnetic waves can travel in their own space. They can travel in empty space by setting down their own electromagnetic fields. And it's not the individual particles that move from place to place in a mechanical wave. They vibrate within their own position, and each individual molecule moves the next particle up and down or left and right, but in a very small area. And that's it for the intro to waves.